Okay, today's lesson is on word equations. Now, when we talk about word equations, we're not talking about, type of equation where we might say pi equals this symbol, and I spelled pi wrong on purpose, just for fun. But we're not talking about that type of word equation. We're not talking about math or equal, where we're going to involve an equal sign. Okay? We're talking about a chemical equation. Chemical equations, when you write it as a word equation, we're representing that reaction based on what chemicals are involved. Now, the general form is that we'll have reactants equaling products. But instead of using an equal sign in word equations or chemical equations, we always use an arrow. You might also see multiple reactants or products. In this case, we introduce another symbol, plus sign, to separate our reactants and products. So general form could be this: reactant A plus reactant B produces product 1 and product 2. So when we take a look at that, we see that addition of the plus sign just to separate our reactants and our products. So we see the use of some symbols. In this case, we use a plus sign. Separate multiple reactants. The arrow is used to represent the word produces or yields or forms. So that's what our arrows are. So when you see those symbols, that's what we're talking about. So let's do a simple example. The production of water. So water is produced from a reaction between hydrogen gas and oxygen gas. So a word equation we could use would be hydrogen plus oxygen produces, so we put the arrow in, water. So there's our general equation. Now that's a word equation, but there is another piece that we might include in a word equation, and that other piece are some more symbols. We might use symbols to represent the states. So you might see these symbols put in. You might see G for gas, S for solid, L for liquid. You might see AQ representing the aqueous state. With acids, that's where you'll see that AQ. Now, in this example with hydrogen oxygen, we know that we used hydrogen gas, so I'm just going to put a G in brackets. I'm going to put a G in brackets behind the oxygen. And because my water I'm probably going to produce will be liquid, I'll put an L behind the water. Okay. Usually you'll see this as a subscript, but it doesn't necessarily have to be. But it's always in brackets after the word. So you're probably thinking, where do we go from this? That's a lot of writing. I got to write words. That's a lot of work. Well, as we know, chemists can be a little lazy at times. They like shortcuts. So one shortcut, instead of writing all the words for these chemicals, we might use what we call skeleton equations. Now, skeleton equation is we're not going to dig up some dinosaurs and look at fossils or anything. When we talk about skeleton equations, we're really just using the chemical formula in place of the words. So in that example that we had, hydrogen gas plus oxygen gas makes water as a liquid, we're going to use our chemical formula. So we know our chemical formula for hydrogen. It's one of those diatomic elements, so it has to be H2. We know the state is gas, so we'll still put that in there. Then we have our oxygen. Oxygen's another diatomic element, so it exists as O2. And we know the state of it is gas. Those react to produce, we put our arrow in, and then our formula for water, we want to convert that to H2O. And again, we'll put in brackets the state, which is in this case is liquid for water. That's an example of a skeleton equation. So just saves the chemist a little bit of time by writing the chemical formula instead of the words. And because now you're master of nomenclature, you'll be able to convert between words and chemical formulas. So let's do a few examples. We're going to write the word equation and skeleton equation for the following chemical reaction. When copper wire is placed in a solution of silver nitrate, a deposit of silver metal forms on the wire, and aqueous copper 1 nitrate is formed. So let's write our word equation. Well, we know that we put copper in the container and we put it into a container of silver nitrate solution. So our word equation would be copper, and that's a solid, plus silver nitrate, and it's a solution, so that means it's aqueous, produces silver metal, which would be a solid, and copper 1 nitrate, which is an aqueous solution. So there's our word equation. Now we convert it to a skeleton equation. What's our formula for copper? It's a monoatomic element, so we just write it as Cu. We still include our state, which is solid. Silver nitrate. So when we take a look at this, we know silver from our PR table has a charge of +1. So our silver has a +1 charge. Our nitrate has a -1 charge. So when I do this, I will get silver Ag and then NO3. And that's aqueous state. This reacts to produce silver. Silver is a metal on the periodic table. Its symbol is Ag. And copper 1 nitrate. So copper 1 nitrate, copper, we're told, is +1. Nitrate, -1. So our formula is CuNO3 and aqueous solution. There's our skeleton equation for that word equation. Let's try another example. Aluminum metal resists corrosion since it reacts with oxygen in the air to form a coating of protective aluminum oxide. Very important reaction, because if we didn't have this reaction occurring, flying in an airplane during a rainstorm would be very dangerous. Now, we take a look. We know our reactants. Our first reactant is aluminum. It reacts with oxygen. So those are our two reactants in this case. So for my word equation, aluminum, and it's aluminum metal, so I'm going to assume it's in solid state, reacts with oxygen, which is going to be a gas, to produce a protective coating known as aluminum oxide. So, aluminum oxide. And it's a protective coating, so it will be solid. It's a nice solid coating. Now, the skeleton equation, we take our fancy word equation and convert it into our chemical formula. So aluminum is just Al, right from the periodic table. Oxygen, diatomic element, O2. And it produces aluminum oxide. Now, this one might take a little bit of work. So off to the side, I'm going to do a little practice here, and I'm going to say, all right, aluminum. Aluminum has a 3+ charge. Oxygen, 2 negative charges, an ion. So when I do my fancy crisscross rule, we're going to see the 3 come down behind the oxygen, the 2 end up behind the aluminum to give us our formula of Al2O3, and we know that this is in solid state, so I'll include my S for my state symbol. And there's our skeleton equation for that reaction. So that's our little intro to word equations and skeleton equations. Make sure you practice these things.